Welcome to the greenhouse. I'm Alex. Let's do an experiment. Come on in. So the greenhouse is a great place to talk about the greenhouse effect. And we're going to do that today by creating an experiment in this little tiny jar. We're going to recreate a greenhouse right in here. But first, let's talk about the greenhouse effect. And to do that, I'll bring up a graphic that'll help us understand what's going on. In a greenhouse, we have sunlight entering through the glass. The glass is transparent to the visible part of the spectrum, and that's what the sun gives off most of. That visible light passes through the roof of the greenhouse, and it warms up everything in the interior. The warm interior also is radiating energy, but the energy that it radiates is in the infrared part of the spectrum, not the visible. The glass blocks the infrared, it absorbs it, so it's not transparent to infrared the way it is to visible light. Now, when we talk about the greenhouse effect in the larger environment, in the Earth's atmosphere, the thing that is absorbing the infrared light are gases like carbon dioxide and like methane. And those gases also absorb outgoing infrared energy. When they absorb the energy, they vibrate and they collide with other molecules in the atmosphere. This raises the temperature of the atmosphere, and it helps keep the atmosphere warm. A few greenhouse gases like CO2 are good in the atmosphere because it makes our planet habitable, but when we get too many greenhouse gases, the atmosphere gets too warm, and that's a problem for natural ecosystems and for human communities. So today, to run this experiment, we need three things. First of all, we need a source of energy, and we're going to use a high-intensity lamp with a light bulb. This is a reptile lamp that you can get from the pet store. And so that's our source of energy. We also need a source of carbon dioxide. We're going to use antacid tablets. This is sodium bicarbonate. These are going to dissolve in water and exhalve off some CO2 gas. And then we need a way to measure the warming of the atmosphere. So we need some thermometers. Now, I've got a bunch of thermometers here, and you can use pretty much anything that will fit in these jars. I recommend actually making sure you have a digital thermometer because that's going to be much easier to read and to record your data rather than an analog thermometer like this. What I'm going to use are some lab thermometers that I can plug into the computer, and this will allow us to collect the data and record it in real time and see what's happening as our experiment goes on. This particular one is neat because it's both a thermometer and a carbon dioxide probe all in one instrument, and so we'll actually be able to watch the CO2 entering the chamber as well as watching the temperature change. Now, to introduce the CO2 into our jars, we have an Erlenmeyer flask with a tube, and we're going to put the tube into one of our jars. If you don't have a flask like this, that's okay. You can use pretty much anything that would fit a tube. For instance, a coffee mug that you can just stick the tube through the top and put your CO2 tablets in here, and that'll work just fine. The other thing that's important in this experiment is you notice I've got two jars. So if we are going to perturb a parameter in the environment, we want to make sure that the perturbation is only from the thing that we're changing and not from anything else. So in addition to having a jar that's going to be our experiment where we're going to introduce the CO2, we also have a second identical jar that's going to be our control. And in this jar, nothing's going to be happening. We're not going to perturb it in any way, but we're still going to monitor the temperature so that we'll have a comparison. Now, the other thing that's important, because we're going to be warming these jars up with this lamp, we also want to set everything up and let it equilibrate with the light on before we start measuring any kind of temperature change, because the jars are going to warm up just from sitting under the lamp. And we want to make sure that they're all warm and ready to go before we introduce our carbon dioxide and see what happens from there. So I'm going to give this about 10 minutes, and then we'll come back and we'll start our experiment. All right, we've let this sit for 10 minutes or so, and the temperature is nice and stable. And so what I'm going to do first is I'm going to begin recording the temperature data for about a minute before we go ahead and introduce our sodium bicarbonate tablets. And that is going to give me just another little piece of a baseline before we go ahead and perturb the experiment. So we have the 2 jars. We're going to create our carbon dioxide here in this flask. And so that way the only thing that's changing in this beaker is the introduction of the CO2 gas through this tube. So we've been going for about a minute. We're going to drop that in and watch what happens. So pretty quickly we can see the carbon dioxide shoot way up. We've used 4 tablets, which is enough to flood this jar with CO2. And now we're going to watch as the temperature changes. All right, so now you can see that after 10 minutes of experimental time, we've actually had about a 1.5 degrees Celsius increase in temperature in the experimental jar compared with our control jar. So we've seen how the carbon dioxide that we introduced into this chamber has warmed the chamber by interacting with the infrared energy coming from this lamp. This is what greenhouse gases do in our atmosphere. But one of the really hard things about understanding what's happening with gases in the atmosphere is that they're invisible. And so by running this experiment, we've been able to visualize the invisible. How cool is that?